Hi, everyone, and welcome to episode 677 of People Behind the Science. Today, we are excited to reshare our interview with Dr. Tamara Bogdanović, originally released on October 10th of 2016. Listeners, Tamara is a theoretical physicist who studies some of the largest black holes in our universe, known as supermassive black holes. In particular, she's been investigating signatures from observational data that are associated with the interactions between these supermassive black holes with gas and stars. And Tamara has received various awards for both her excellence in research and her teaching. And she talks more about her work and her life in this episode of People Behind the Science.
Every day, discoveries are made that will change our understanding of the world around us. Dr. Marie McNeely is here to bring you the brilliant minds who are making these discoveries so they can share their incredible stories and take you on an amazing journey. Welcome to People Behind the Science.
Hello, everyone, and welcome to another episode of People Behind the Science. Today, I am thrilled to introduce you all to Dr. Tamara Bogdanović. So, Tamara, thank you so much for joining us on the show. How are you?
I'm doing very well. Thank you for having me.
Absolutely. Well, we are excited to learn more about you and your work, but let me take a moment to introduce you to our listeners first. So, listeners, Tamara is an assistant professor in physics at the Georgia Institute of Technology. She received her bachelor's in astrophysics from the University of Belgrade in Serbia and her PhD in astrophysics from Pennsylvania State University. Tamara then conducted postdoctoral research at the University of Maryland, where she received a NASA-sponsored Einstein postdoctoral fellowship, as well as an Astronomy Prize Theory postdoctoral fellowship. She has also been named an Alfred P. Sloan Research Fellow, a Cottrell Scholar, as well as a Colin Peck Fellow. And listeners, Tamara is here with us today to talk about her experiences in life and science. And Tamara, today we want to learn a little bit about you and your research. So can you start by telling us what you like to do with your time when you're not doing science?
Well, when I don't do science and I don't teach physics and astrophysics, I love to spend time outdoors with my husband, hike in the woods, or just walk in our neighborhood. I also enjoy doing yoga, preferably with a group, since then I find I'm more focused. And reading has always been one of my selfish pleasures. So that's something that I do when I want to escape the world and immerse myself in a different reality.
I love it. Well, Tamara, I'm sure you're aware we love to get book recommendations from everyone we have on our show. So can you tell us, what is a book you're reading now or one that you've really enjoyed that you can recommend to us?
I can tell you perhaps about a book that I read, and it's a book unrelated to science. So some time ago, I actually read the autobiography of Mark Twain, edited by Harriet Eleanor Smith and others, which was published in 2010. This is actually a hefty book, given that it's only the first of the 3 volumes and it abounds in editorial and scholarly notes. Mm-hmm. What actually comes across in it very clearly is the extraordinary spirit and a quick wit of a man who gave the world Tom Sawyer and Huckleberry Finn, and actually with this book managed to publish yet another bestseller 100 years after his death. I quite enjoyed it and finished the book thinking that if Twain was still alive, I could imagine him being my good friend. I think that the 2 remaining volumes have been published in the meantime, and I'm actually looking forward to reading them too.
Awesome. So do you typically find yourself gravitating towards non-science books when you're looking for something to read?
Oftentimes, yes. It provides a break from the science side, but I'm an equal opportunity reader, and I will read many different types of books, science included.
Excellent. Well, I will definitely put your recommendation out on our website for our listeners to find if they are in search of maybe escaping science for a little bit. But I do want to talk about your research next. So, Tamara, can you give us maybe the big picture idea of how you describe your work to someone who's not familiar with your field?
I am a theoretical astrophysicist, and I research some of the most massive black holes in the universe, also known as the supermassive black holes. My group investigates observational signatures associated with supermassive black holes interacting with gas and stars in the nuclei of galaxies. And my goal as a theorist is to predict the signatures of these interactions, which can be searched for in astronomical observations of distant galaxies, as well as to provide interpretation for some of the puzzling astrophysical events in the sky.
Very cool. So just to give us a sense of scale, if you can, how big are these supermassive black holes that you study?
Well, the black holes that we call supermassive typically have masses that are millions to billions of times larger than the mass of our sun. So usually we think each galaxy has one at its center, but occasionally a galaxy may have more than one.
Interesting. Well, I am looking forward to chatting more about your work as we go through the interview, but I want to get a little bit of insight into what motivates you first. So can you tell us, do you have a particular motivating force that keeps you going in science, or a favorite quote or a saying that you like to keep in your mind?
I guess I will have to quote one of the greatest philosophers and Jedi masters, Yoda.
Awesome.
Who said that a Jedi uses the Force for knowledge and defense, never for attack. I think that we should all aspire to that goal and be a part of the Force for good.
Tamara, I love it. So I'm guessing here, are you a Star Wars fan?
That's a pretty safe guess, yes.
Yeah. Very cool. Fantastic quote to keep you motivated. And this idea of scientists being a force of good, I think, is really important for people in society to think about. So now, can you tell us a little bit more about some of these people who you've looked up to as role models?
I would say that my parents have always been a very important influence in my life, an early influence. And later on, my graduate and postdoctoral mentors, who are people that I very much look up to, not only because they're excellent scientists, but because they're wonderful people who taught me many important things. There are probably many, many others, but those are the people that I will mention.
Definitely. So you mentioned your parents first. Were they scientists as well?
No, actually they were not, but they were very supportive of my career choice.
Gotcha. So can you tell us where your interest in science began? Maybe take us all the way back to the beginning, Tamara, and tell us what first sparked that curiosity for you.
Well, my journey starts in Serbia, the country where I was born. I grew up in a small town and had a fairly carefree childhood. I wanted to be many things as I was growing up, a ballerina, a writer, an architect, to name just a few. But astrophysics did not come up until later, actually.
Mm-hmm.
So one thing I knew relatively early on is that I enjoy solving challenging problems. In the same way that others find excitement and satisfaction in reaching a mountain summit or in mastering a video game. So whatever profession I picked in the future, it had to provide a fresh set of problems to work on. Then at some point in high school, I actually learned about astrophysics. I didn't have a very clear idea about what astrophysicists do on a daily basis, but it sounded like a perfect adventure for me, one that married the things that I liked about math and physics. I applied to and I was accepted to the bachelor's program in astrophysics at the University of Belgrade in Serbia. And my choice to study astrophysics was actually an unusual one, to say the least. Very few people pursued it in Serbia, and job prospects were not entirely clear.
Mm-hmm.
Some of my high school professors actually questioned my decision, pointing out correctly that a career in engineering would be a much safer and perhaps sensible choice, given the times. My parents, however, were very supportive of my decision, and if they had any doubts about what I'll be doing in the future, they didn't show it.
Sure.
So during my college years, in the late 90s, my country was going through some particularly turbulent times that included wars and a NATO bombarding. And it indeed was not obvious that astrophysicists will be in high demand anytime soon. I knew back then that astrophysics was it for me, and that I wanted to pursue a PhD. So I applied to PhD programs, mostly in the United States and some in Europe, and was accepted by several. And in the end, I decided to pursue a PhD in astrophysics at the Pennsylvania State University. So when the time came to leave Serbia, I was thrilled and terrified at the same time.
Mm-hmm.
Thrilled because a great new horizon was opening ahead of me, and terrified because I had never been in the United States, and I was about to leave my family, to which I'm very close, and many of my friends. It was a step into the unknown, about which I had a great deal of mixed feelings, but which I ultimately wanted to take.
Sure.
Grad school then was a wonderful period of time. It was a lot of work and a lot of fun, as well as a time when I met a lot of new friends with whom I remained very close. After I graduated from Penn State, I started a postdoctoral position at the University of Maryland, where I became a part of a vibrant research group and made some of my own important scientific breakthroughs. That put me in a good position to win one of the very competitive NASA's Einstein postdoctoral fellowships, which allowed me then to fully and independently pursue my research. which professionally was a great experience that I really enjoyed. And personally, it was exactly the kind of adventure that I signed up for.
I love it. Well, Tamara, this is a fantastic story. And I think you brought up so many important points that I want to just touch on a few of them. So you mentioned initially when you started thinking about careers as a kid, you wanted to do a variety of different things. Was there ever a point where you started considering other career options? Because then you mentioned further on, people were maybe pushing you in other directions, pushing you towards engineering, pushing you towards these other fields that maybe there was more job security. Was there ever a point where you contemplated giving astrophysics up?
Actually, I was very, very close to take one of the entry exams again and apply for mechanical engineering because comments by my high school professors made me really, really nervous. I was pondering and thinking about it for a while, and then I talked to my parents. And my parents were really, really supportive and basically said that I should go ahead and do what I think will be best and what I truly love. And at that point, I made up my mind that I will pursue astrophysics because I was already accepted into that program. And the rest is history, I guess.
Sure. So what was it about astrophysics that really initially captivated you? Do you remember?
I think that it was the promise of adventure, that I knew that there are many, many great problems to solve. But also at the same time, I wasn't entirely sure where is it going to lead. It was this combination of things that just worked for me. And it also involved things that I already liked about math and physics. And I had a hard time choosing between the two, one or the other. So this just was a perfect solution for me.
Certainly allowed you to pull both of those passions in. I like it. So now, can you tell us a little bit about your experiences in undergraduate? I'm not very familiar with the educational system in Serbia. Was it challenging to do the astrophysics work there? You mentioned there aren't very many people who do that.
Yeah, certainly. The astrophysics groups are very small. So at the time when I was an undergraduate student there, it was perhaps a group of 10 students in my class.
Oh, wow.
Maybe one or two less even. So it was basically a degree that was formerly part of the Department of Mathematics for traditional reasons, but we were taking both a lot of math and physics courses. Interestingly, back at the time, the Department of Mathematics had a lot of female students, probably more than 50%. So I felt perfectly at home. It was a great experience, actually, studying astrophysics back at the University of Belgrade, and it gave me a really good foundation to pursue a PhD later on.
Absolutely. And speaking of your PhD experience, you mentioned you were excited, but maybe a little bit nervous going to the United States. What was it like, maybe your first couple weeks or first month there in the United States after having left Serbia behind?
It was fascinating, and some things certainly felt very different. So at certain points in time, it felt like a different planet. But again, it was a great sense of adventure that kept me going. And I just look back at that time as a very happy period of my life.
Wonderful. And I know your adventures are continuing in the lab today. So Tamara, can you tell us about a project that you have ongoing at this moment that you are so excited about?
We do have several ongoing projects in my group that I'm very excited about. So this feels a little bit like picking a favorite child, all being equal. Let me mention supermassive black hole binaries, a topic on which I have been working on for a number of years now. So gravitationally bound pairs of orbiting supermassive black holes are actually thought to be a natural product of collisions of galaxies. And these we know happen because they have been seen in observations. Supermassive black hole binaries, however, remain elusive and very difficult to identify in observations. We are currently collaborating with a team of observers who are using spectroscopic observations of distant galaxies in order to select those which are promising candidates for hosts to supermassive black hole binaries. In parallel with multi-year observations, my group has developed a theoretical model which will be used to interpret the spectroscopic signatures of these observed binary candidates. Namely, assuming that they are true binaries, our models will be able to provide some important information about the properties of these systems, such as the relative mass of the primary and secondary black hole, the size and shape of their orbit, and so on. This information is important to a number of subfields in astrophysics that investigate how galaxies and their supermassive black holes evolve through cosmic time. At this point, our collaboration has collected a sufficient amount of data that will allow us this type of analysis, which I anticipate will happen over the next year. That will be a combination of lots of work by many scientists. I'm actually looking forward to seeing the results.
Well, this sounds like a really cool project, Tamara. You mentioned that you are collaborating with a lot of different kinds of scientists on these projects. So do you get to spend time observing, or is that something that typically this group of observing astrophysicists do?
So usually observation and 3 astronomical observatories are done by scientists who are trained to do so. We just call them observers, but they would be an equivalent of experimentalists in physics and other fields of science. So I typically don't get to go observing, although I have done so when I was a graduate student on one occasion.
So I know you mentioned when you were talking about your past, your history, and what got you excited about science, you didn't really have a good sense of what a day in the life of an astrophysicist looks like. So can you maybe give us a window into what a day in the life of your research looks like?
I actually don't have a lab. Being a theorist, my computer is my lab. Mm-hmm. But I do have a research group that I work with. So if there is a typical day, I'd say that would be a day when I meet with my students and my postdoctoral researcher to discuss progress on one of our projects. We also meet together as a group to talk about interesting articles, discuss what's new in our field, and just generally make plans for our group activities and our research activities. I also teach a couple of times during the week, so I also meet with my students whom I'm teaching modern physics this semester. And we then chat about homework assignments and basically discuss any questions that my students may have about the topics that we are learning in class.
Well, it sounds like this theoretical work is a lot of fun, great opportunities to collaborate with people across the field. So fantastic to hear more about your work in this exciting project you have going on now. But I know there are challenges, there are struggles in science, and most days are fun. But we also have these downtimes as scientists where we're frustrated with things and having trouble getting things to work. So is there a challenge or a failure, Tamara, that you can tell us about today and maybe give us some hints to how you got through it?
Yes, there are certainly times like that. And I can discuss some of my experience without any intention to make it scary for those who are in love with science and plan to take on that route. Mm-hmm. So around the time when I started applying for faculty positions in a number of countries, the astronomy job market tanked, actually. So because of the ripples sent across the world by the global economic crisis, a large number of universities instituted a hiring freeze on faculty over a period of a few years. So just to give you a sense of perspective, faculty positions in astrophysics are very competitive, and the job market is quite international on any given year. So the financial crisis had been a big impact on this relatively small field. And back at that point, the words of my high school professor were echoing in my head once more that a career in engineering is a much safer choice.
Seeing all those openings in engineering and right.
Right. So at that point, it was very difficult to think and plan for contingencies, not knowing whether I will need to completely rethink my career and whether I will be able to live and work in the same country or, for that matter, continent with my husband. My immigration paperwork and my work permit at the time were directly tied to my research position in astrophysics, so being without a job also meant having to leave the country in which I have already spent 10 years as a researcher. Mm-hmm. My husband, who is a researcher in molecular biology and genetics of plants, was in a similar position. So all these felt more as a failure than a success. And on certain days, I struggled to justify to myself that any job is worth so much trouble. I was totally resigned to whatever outcome when I received an invitation to an interview for a position at Georgia Tech in Atlanta, Georgia, which was an excellent match for my research expertise. Some months later, my husband incidentally found a great job opening in a lab at the Emory University, also located in Atlanta, calling for the exact expertise that he possessed. So what seemed impossible actually happened, and we both ended up accepting positions that we truly wanted and in the same city.
I love it. Well, I'm so glad this story had a happy ending. And I think the two-body problem that people describe as scientists is a challenge, right? Trying to find a city you can land in or a place you can land in that has two perfect fit positions. And it sounds like you guys made it work perfectly. I'm impressed.
I'm impressed as well.
Well, congratulations on this faculty position. It sounds like you turned what could have been a really challenging, a really difficult time into an amazing success. So fantastic job with that. And I'm so happy to hear, like I said, that you and your husband were able to find that perfect fit position there at Georgia Tech and at Emory University in Atlanta. So can you tell us what are some of the things that helped you get through it on those down days where things were really looking dismal?
Basically, patience. Patience was an important part of it. And I guess confidence that good work and good results eventually lead to something good. And perhaps a pinch of luck, I would say, doesn't hurt.
Of course.
On such days. So I think that those three factors are the ones that I would mention.
Absolutely. Well, fantastic to hear about this challenge that you were able to turn into a success. And I love talking about all the different successes that scientists face, not only getting career positions, but successes in research, successes in life. So I want to talk more about these next. Tamara, is there another success story that you could share with us, whether it's a big win or even just a small victory that really meant a lot to you?
Well, I guess in science and research, there are many ways to judge success. Some of them are more inward and based on criteria that we set for ourselves. Some are outward and come in the form of recognitions bestowed upon you by others. So let me talk about the former kind first. A very important aspect of the job of any junior faculty at a research university is to assemble from scratch and train a research group of students and postdoctoral researchers which within only several years can make expertly contributions to their respective science field. So being a human endeavor, this process does not always follow a linear path,
right?
But it is very important for all of its mentioned stakeholders. To my great delight, my research group reached this threshold of productivity about a year or two ago, and we have since made contributions on a number of different research topics. When it comes to success of a more outward kind, this year I was greatly honored, as you mentioned earlier, to receive 2 awards in recognition of my research and teaching scholarship. One of them is a Cottrell Scholar Award, given by the Research Corporation for Advancement of Science, and the other was a Coulomb-Peck Fellowship given by the Georgia Tech College of Science.
Well, congratulations on both these inward and outward successes. I know a lot of people do point to this period of starting your laboratory as a new assistant professor as one of the most challenging parts of the career. So it sounds like you're over the worst of it, right?
Yeah, I feel like I'm over the hill.
Yeah. So congratulations on the success of your students and postdocs, and wonderful to hear about these awards as well. So can you tell us, do you remember where you were when you received notification that you received these 2 awards?
When I heard about the Cottrell Scholar Award, I actually received an email, which did not explain what is it about, but it was from the Research Corporation for Advancement of Science, and it was an email that was a request for a phone call.
Interesting.
I was not sure whether it's going to be a good or bad news, but I patiently waited for the phone call, and I heard good news, basically.
Oh, that's awesome. I think it's more personal when it's delivered over the phone rather than just in kind of a generic email form. So
yes, it was great. When I heard about the Coulomb-Peck Fellowship, I was actually very surprised because I didn't even know that I was nominated. And basically, I'm very grateful for the support from my school and my chair, who was the person behind the nomination, and just mentioned once in passing that he's thinking of nominating me for an award, but actually never told me what award that was. So
really, I
never was anticipating or expecting anything. I very quickly forgot, actually. So this was a complete surprise and an awesome one when I heard about it.
Well, that is amazing. Again, congratulations on all of these fantastic accomplishments.
Thank you.
And in talking about your career, we mentioned that you traveled a great distance to attend graduate school here in the United States for your PhD programs, and then you've stayed on since then. And I think travel is a big part of life as a scientist, not only as you're going through your training, but for conferences and different opportunities, working with collaborators. So can you tell us a little bit, Tamara, about some of your travel experiences, and maybe if there's one that really sticks out in your mind as the most memorable?
Yeah, there were many great trips, but I will have to say Hawaii, which is a truly magnificent place, but that is not the only reason. So in 2010, I was preparing for a fairly busy schedule of talks and activities at the meeting of the American Astronomical Society in Hawaii, and musing with my now husband how it would be great if he too came along. We were not married at that point, partly because we had trouble coming up with a perfect location. Lots of our friends were located in the United States and around the world, and our families and relatives in Serbia, where we are from originally, but in different cities. So the logistics was a bit complicated.
Gotcha.
Then, a mere week before the meeting in Hawaii, an idea struck out of the blue. Why don't we just get married in Hawaii after the conference is over?
Wow.
And so we did. We got married on a sunny day on a beautiful sandy beach with only an officiant and a photographer in attendance. And we celebrated with friends and relatives later. And I would say that's what made that conference trip very special.
Absolutely. Well, I'm impressed you pulled together everything in a week then. Right.
It was a pretty short notice, but we made it, yeah.
Yeah. So then did you find it hard to focus at the conference, thinking about your impending wedding coming right after it?
Interestingly, not really.
Really?
I was excited, yeah, but I was able to just patiently wait, finish with my talk and other presentations, and then turn around and do a completely different thing. So that was a great trip.
Absolutely. Well, it sounds like it is certainly a memorable trip with your wedding planned right there at the tail end of the conference. So can you tell us a little bit about what were some of these things you were able to do at the conference?
Well, conferences, and especially the meeting of the American Astronomical Society, are great networking hubs. So whenever I go to one of those meetings, they're very, very busy. Usually there are 2,000 or 3,000 astronomers in a meeting, and there are many people that I know. Either my former classmates, my former teachers, colleagues from universities where I used to work previously. So it really feels like a place where I'm at home. And it also feels like a place where I constantly talk around the clock to to many different people. More recently, I have started taking my research group to these conferences, and that usually means that I make sure that everybody is set up to show their poster or give their talk, and I attend their talks and network and introduce them to some of my colleagues and other researchers in the field. So usually these are very vibrant events. They are also very social. A lot of great science is discussed during them, and I always enjoy going.
Definitely. So I must ask, did your colleagues at the conference know that you were getting married right afterwards?
No, most of them didn't, because remember, we only decided a week before, so
right.
It was impossible to actually announce it or have a big group of people attending.
Sure.
But I would say it was just perfect. All that we wanted. And we had an opportunity to celebrate with everybody else later in all these different cities in the world.
Well, it sounds like a perfect dream wedding with, like you said, these scattered receptions then you could have afterwards with all your different groups of friends and family over the world. So
perfect solution, right?
Absolutely. Only a scientist could come up with it, right? Well, I love one of the things that you pointed out about these conferences, too, that they're very social. And I think this is maybe contrary to the stereotype that a lot of people have in their minds about what scientists are like. But there are so many different personalities in science. And I think these manifest themselves in conferences, these very social events, but also in some of the laboratory personalities and quirky traditions and just fun things that you do with other scientists. So, Tamara, do you have a story that you can share with us that kind of shows the human side of science?
Well, yeah, one fun tradition that a group of us astrophysicists started at Georgia Tech is called the Faculty on the Hot Seat series.
Ooh.
Where we have a faculty take any questions from the audience, including students, postdocs, and other faculty, that can be about their work, but also their life, their experiences, a favorite dessert, or you name it. So this is a very popular event, and we often have lots of laughs. And we also get to know each other a little bit better and show our students the human side of science. Basically, that faculty and professors have this funny side as well.
Absolutely. And I think it's really important to have these conversations, to show people that you're an exceptional scientist, you're brilliant, but you're also a person. You do normal human people things. So.
Yes, I very much agree.
And you brought it up. So what is your favorite dessert, if I may ask?
That is a very good question. I'm very undecisive right now, but let me go with tiramisu.
Oh, that is a solid choice. I know we're getting towards lunchtime, so this is making me hungry. Well, fantastic to hear more about one of these traditions. And I think this is a great opportunity, like you said, for students to kind of get to know the faculty a little bit and maybe see a different side of the faculty than they would normally see in the classroom. Well, in addition to talking about some of the fabulous traditions that scientists have in their laboratories, I also like to talk about some of these big questions that scientists have burning in their minds. And I know you're not able to easily answer all these questions with your research, so it seems like everyone has these outstanding questions that they just can't address right now. But if I gave you everything, funding, staff, technology, feasibility, no barriers, is there one question that you have that you are just dying to answer?
That would have to be a research question about supermassive black hole binaries, the project that I mentioned earlier. The question that I would like to answer very much is which galaxies are hosts to supermassive black hole binaries and what are their unique observational signatures? So we've been after this question for a number of years now, not only us, but other research groups too. And that's the one that I would ultimately like to answer.
So if you had to pick maybe one or just a few, what are some things standing in your way between you and getting that answer?
Well, one part of it is that detecting black holes is not always easy. As you may know, they're dark objects and use their name. Black holes, they don't emit radiation or electromagnetic radiation. So the best that we can do is detect them indirectly when they are accreting gas or stars, because these emit light and basically we use them as luminous tracers of black holes. So in order to be sure that one has really observed a supermassive black hole in a distant galaxy requires a lot of follow-up observation with high precision. Another obstacle, I would say, is that we don't really have all theoretical pieces in place. Environments in which black holes live are very complex, and we are able to model and simulate in our theories some key features, some salient features of these environments and the light that they emit and their signatures. But ultimately, these are very complex nonlinear systems, and we cannot model every single detail. And it just so happens that in losing that detail, we use some very important information so that we cannot make a unique prediction about the observation signatures of these systems, which is why theory and observations have to come together in order to solve this problem. So neither one by itself will be enough.
Certainly. Well, it sounds like there are a lot of challenges out there, but so many exciting opportunities to start to chip away at answers to these kinds of questions that you're asking. So wonderful to hear about one of these big questions that's burning in your mind unanswered. And as you go through your career answering these questions, I think you get a lot of great advice along the way from a wide variety of different people. So Tamara, is there one piece of advice that sticks out in your mind as just the best piece of advice you've ever received?
I honestly don't remember. I would like to think that it was not wasted on me. Mm-hmm. But all I can seem to think of is always look on the bright side of life, a song written by Monty Python.
I like it.
By itself is a pretty good advice, so I'll go with that.
Absolutely. Are you a Monty Python fan in addition to your Star Wars interests?
I indeed am, yes.
Yeah, we've done Monty Python marathons before. They're always a lot of fun. So.
I wish I was there.
I will have to invite you to the next one. It's going to happen.
I would love that. Thank you.
Well, Tamara, wonderful to hear about one of these helpful pieces of advice. Is there any other last piece of advice you want to leave our listeners with, or one last note of inspiration you want to end our conversation on?
Perhaps this one. There will inevitably be times when, despite hard work and exemplary results, things don't go your way. On such days, lots of patience, belief in yourself, and a pinch of luck can go a long way. But then you may not remember this advice later if you're like me, so. Yeah.
As long as you keep that optimism, that looking on the brighter side of life, you'll be fine.
I guess so, yeah. Yes.
I like it. Well, Tamara, wonderful to chat with you today. Can you tell our listeners how they can reach out if they want to learn more about you and your work?
Well, they're welcome to reach me via email at tamarab@gatech.edu.
Fantastic. Well, listeners, definitely reach out if you have any questions or want to get in touch with Tamara. And Tamara, thank you so much for joining us today on our program.
Thank you very much for having me. It was a pleasure.
Well, it has been so much fun to chat with you. And listeners, wonderful to have you here as well. We'll see you next time on another episode of People Behind the Science. Your voyage to explore the lives of today's exceptional scientists has just begun. You can find everything we talked about today, including our guests' favorite books, biographies, photos, and more, when you visit us at www.peoplebehindthescience.com. I look forward to chatting with you next time on People Behind the Science.